Hello, everyone. This is Richard Epps, and this presentation will cover technology integration models. It may be a little long, however, there is a lot of information covered. So please watch the video, and I look forward to your feedback.
If a teacher were asked to rate the level of technology integration in her class using a scale with 0 representing no technology to 10 representing fully integrated, they may have a tough time doing so because there is a lot of information missing. Like, what do we mean by integrated? Are we talking about the teacher? Are we talking about the students? How about the course material, assessments, student accountability, internal versus external resource use, availability of technology, and so on? This scale really does not tell the whole picture. The person asking this of the teacher may try to add details to the question by asking the teacher to rate based on the type of learning or pedagogical approach, to say student independence or level of transformational learning. Now, our teacher has a little more information and could possibly give a more accurate answer. The problem would still be a lack of definition because multiple teachers may view a classroom with the exact same technology differently. This is why standard framework models are used for assessing the level of technology integration. Using this standardized language, teachers can identify and report their level of integration. In fact, some of the models lend themselves to planning future integration. Our discussion will cover 5 technology integration framework models: the TPAC model, the TIP model, the SAMR model, the LODI framework, and the TIM model. I know that's a lot of acronyms. Don't worry, we will cover them all during this presentation. For each model, we will introduce each framework, explain the purpose of the model, and then discuss how they are used. The Technological Pedagogical Content Model, or TPAC, builds on the work of Dr. Lee Shulman, whose work suggests that teaching has a knowledge base. He argues that teaching requires knowledge of the content, knowledge of pedagogy, and knowledge of students. He claims that these compose what he calls pedagogical content knowledge. The current TPAC model came about over several modifications by various education theorists, with the latest being the 2008 edition of the Outer Ring for Context. The model focuses on the relationships between technology, pedagogy, and content. The TPAC model attempts to identify the nature of knowledge required by teachers for technology integration in their teaching, while addressing the complex, multifaceted, and situated nature of teacher knowledge. Let's build this framework. It starts with pedagogical knowledge, which includes knowledge about how students learn, teaching approaches, methods of assessment, and knowledge of different theories about learning. Next, we bring in content knowledge, which refers to the facts, concepts, theories, and principles that are taught and learned in specific academic courses. When we bring in technological knowledge, it is in the context of the teacher's knowledge of and ability to use various technologies, technological tools, and associated resources effectively in their instruction. As these areas overlap, we see a synthesis of knowledge. The intersection of each area is critical because they represent deeper levels of understanding. The overlap of teaching and content speaks to pedagogical content knowledge, which speaks to the combination of teaching and content effectively. This is knowledge about how to make a subject understandable to learners. Here we are talking about understanding the best practices for teaching specific content to your specific students. The second overlap is created with the intersection of technological and content knowledge, and refers to knowledge about how technology may be used to provide new ways of teaching content. An example would be the use of animation to explain concepts. The intersection of technology and pedagogy refers to the benefits and constraints of technology as an enabler of different teaching approaches. In other words, the understanding of how to use digital tools as a vehicle to the desired learning outcomes and experiences. The center, where all 3 knowledge areas merge, is the sweet spot and is known as TPAC. It represents a full understanding of how to teach with technology. Keep in mind that this is not the same as having knowledge of each of the 3 primary concepts individually. Instead, the point of TPAC is to understand how to use technology to teach concepts in a way that enhances student learning experiences. Surrounding our model is the context. This speaks to the environment in which teachers operate, such as schools, classrooms, and cultures. Factors such as the individual educator, the specific grade level, the class demographics, and more will mean that every situation will demand a slightly different approach to technology integration. Our next model is the Levels of Teaching Innovation Framework, or LOTI. It was introduced in 1994 by Dr. Chris Morsch as a research tool to assess authentic classroom technology use. After several iterations, the model we see today is used to measure teachers' implementation of the tenets of digital age literacy as outlined in the National Educational Technology Standards for Teachers. The low-T model focuses on the delicate balance between instruction, assessment, and the effective use of digital tools and resources to promote higher-order thinking, engaged student learning, and authentic assessment practices in the classroom. Quite simply, this means technology integration is measured using 8 levels numbering from 0 through 6. I know that doesn't add up to 8, that's because this tricky little model further divides level 4, but we'll talk about that later. Shown here are two depictions of the model. To the far right, you see a flowchart version that simplifies the process of walking through this model. On the left, you see the Venn diagram graphic scale that resembles a flower and is the traditional depiction of this framework. We will use this traditional graphic to examine this model. Let's build and examine the low-T model. On our vertical axis, we have a complexity scale that goes from low to high cognitive skills. On our horizontal axis, we are moving between types of learning to types of activities. Building from the lower left corner, we have teacher-directed learning. This is very specific and directed teaching. The opposite of this would be practice-based learning, where the students are practicing the concepts on their own. In the upper left quadrant of our diagram, we have student-directed learning where the emphasis is shifted from teacher-directed activities to enabling students to regulate their own behavior and work toward self-selected goals. Opposite this would be problem-based learning, where students are working in groups to solve an open-ended problem. Now that we've established our quadrants, let's look at what's here as far as technology integration. The lowest level would be level 0, non-use, which doesn't show up on the framework. At this level, there is no recordable use of technology. Think of the traditional classroom from 1950. At LOTI level 1, awareness, student learning focuses on lower levels of cognitive processing, think Bloom's taxonomy levels, remembering and understanding. Technology here is non-existent or is only used by the teacher to enhance course material. At LOTI Level 2 exploration, technological resources are now being used by students for extension activities, enrichment, or information gathering. Think a short trip to the computer in the back of the room to look up something. At LOTI Level 3, infusion, the students start using higher levels of cognitive processing, such as reflective thinking or problem solving. Technology is now regularly used by both teachers and students. However, students mainly use technology to execute directed tasks. Now we move a little further up the complexity scale and enter LOTI Level 4, integration. This is where things get a little complicated. Level 4 is split into two subsections, 4A, mechanical use, and 4B, routine use. In 4A, students use technology to explore real-world issues and solve problems. However, there may be challenges such as inconsistent connectivity, lack of support, or disciplinary challenges with students. As these challenges are overcome, we move into LOTI 4B, routine, where the teacher is in their comfort level and student use of technology is inherent, and students are motivated to answer student-driven questions. Even further up the scale, we arrive at LOTI 5 expansion. Now student exploration is expanding beyond the classroom and the inherent use of technology enables students to seek in-depth exploration of academic content and to collaborate with others. At the top of our scale, we see Lodi Level 6, Refinement, where collaboration is extending beyond the classroom using technology. Here there is seamless use of technology for creative problem solving and creativity. Our next model is the substitution, augmentation, modification, and redefinition model, also known as SAM-R. This is a model designed to help educators infuse technology into teaching and learning. It is one of the simplest models to follow. Popularized by Dr. Ruben Puentedura, the model supports and enables teachers to design, develop, and infuse digital learning experiences that utilize technology. The goal is to transform learning experiences so they result in higher levels of achievement for students. The SAM-R model has 4 steps: substitution, augmentation, modification, and redefinition. The lower levels, substitution and augmentation, are considered enhancement steps because they enhance student work, while modification and redefinition are termed transformation steps because they have the ability to significantly modify student work and provide previously inconceivable abilities. At the substitution level, technology is directly substituted for a more traditional one. It is a simple, bare-bones, direct replacement, such as a word processor being used instead of pen and paper or a typewriter. At the augmentation level, the tool is substituted with some improvement to the student work, such as using the spelling and grammar tools in the word processing software. At the modification level, the first level that transforms student work. Here there is a significant redesign of the tasks such as peer sharing, classmate feedback, or automatically building graphs from data. The key is if the technology significantly alters the student's work or the student's task, then there is a modification effect. At the highest level, redefinition, the technology enables the creation of tasks, features, or abilities such as publishing documents online, and the ability to collaborate worldwide. This model is simple and straightforward and easily understood. However, that simplicity is because the model is singularly focused on how content is impacted by technology. This model does not address pedagogy. Now let's turn our attention to another model. The Technology Integration Planning (TIP) model. This model is designed to supplement the findings of tools such as TPAC, which determines what level of technology integration is being used. Teachers use the TIP model to plan the integration of technology into teaching using a 5-phase approach. The TIP model starts with the teacher asking, "Should I incorporate technology?" Here the teacher is trying to determine the advantage of adding technology by focusing on the problem she is trying to address and looking for evidence that technology-based solutions can improve her lessons. She also considers the impact on teaching and learning and the effort and expense to add the technology. Satisfied with the answers to the questions in Phase 1, the teacher moves to Phase 2 to determine the outcomes, objectives, and assessments she expects from using the new method. Here she focuses on the results and not the process. Our teacher then turns her attention to figuring out how she will integrate technology. This is done in Phase 3, design the integration strategy. She determines her teaching method and approach as well as considering the topic characteristics. She decides where to integrate technology. In planning, she also considers student needs as well as the limitations or constraints. This plan includes time to distribute tools and allow time for students to get comfortable with using them. In Phase 4, our teacher prepares the instructional environment. Here she addresses student access issues, privacy and safety issues, conducts test runs and troubleshoots, and most importantly, builds her backup plan. Lastly, in Phase 5, the teacher evaluates and refines the integration strategy by looking at what worked well and what needs to be improved. The TIP model is more of a planning tool than a reporting model. It provides phased steps to enable teachers to thoroughly consider multiple factors in integrating technology. Our final model is actually a matrix. The Technology Integration Matrix, TIM. Chalk notes that this model was created by the Florida Center for Instructional Technology and was meant to be a comprehensive framework for evaluating technology integration in the classroom. Although it was originally created to provide administrators with a resource for teacher evaluation, the framework also gives teachers a different way to think about their use of technology. As noted by Johnson, Holland, and Mera, the model is comprised of 25 cells in a 5 by 5 grid and incorporates a continuum of 5 levels of technology integration, each progressing from teacher-directed learning to more student-centered learning. These levels are entry, adoption, adaptation, infusion, and transformation. Simultaneously, the TIM lists 5 different learning environments found in classrooms: active, collaborative, constructive, authentic, and goal-directed. This model focuses on teaching and the pedagogical approach used. As users move to the right, the model shows greater ownership of learning. This model is very detailed and provides a prescriptive method of integrating technology. Thank you for viewing this presentation. These are the references used to complete this project. I hope you found it informative.